Welcome, geniuses. I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Let's have a discussion on this question of the year 2018, May-June paper, variance 33. A question that is related to the differentiation chapter in the paper 3. The equation of the curve is given where the a is a non-zero constant. So for part 1, you are asked to find out the dy dx is equals to 2x squared minus y squared over y squared plus 2xy. Alright, so for this equation, it's actually an implicit equation. So we have to differentiate this equation with respect to x. So for the part 1, let's differentiate for the left hand side. When you see 2x cubed here, you just differentiate as usual. Then you get 6x squared. And the next term is negative y cubed. When you differentiate, you get 3y squared and times with the dy dx. As for the third term here, you should notice that it's a product of the 3x multiplied with the y squared. So you should treat the 3x as your u and the y squared as your v. So let's open up a big bracket here. And according to our formula, it's u dv plus v du. So what we need to do is copy the 3x, differentiate the y squared. Differentiate the y squared, you should get 2y dy dx. Plus, copy the y squared, differentiate 3x. And equals to the right hand side, we need to differentiate as well. And there is a common mistake here. A lot of students will treat the a as a variable and they will say that, okay, differentiate 2a cubed is actually 6a squared. But it's actually wrong, because here they mentioned that the a is a non-zero constant, which means it's actually a constant. So 2a cubed is a constant. So when you differentiate a constant, it should be equals to 0. Alright, so that's how we differentiate to get the dy dx. So the next step will be just rearrange the equation. What we need to do is we need to group the dy dx together and the terms without dy dx together. So let's say 6x squared is here. The next term without the dy dx will be this term. But remember, you need to multiply the negative into here. So the next term will be just negative 3y squared. And for the terms with dy dx, we should put at the other side, which is 3y squared dy dx plus 6xy dy dx. And what to do here, we should factorize the dy dx and left with the 3y squared plus 6xy in the bracket. And from here, we can conclude that the dy dx is actually equals to 6x squared minus 3y squared over 3y squared plus the 6xy. So let's compare to what they asked to prove. We just need to simplify further. Then you get 2x squared minus y squared divided by y squared plus 2xy. That's how we do for part 1. For part 2, you are asked to find the coordinates of the 2 points on the curve at which the tangent is parallel to y-axis. Usually, the question will be about parallel to the x-axis. When it's parallel to the x-axis, we can mention that dy dx is actually equal to 0. But now, this question is asking about the tangent is parallel to the y-axis. So imagine your tangent line this is the y-axis, this is the x-axis, and the tangent line is parallel to the y-axis. So what can we conclude from the dy dx here? So when a tangent line is parallel to the y-axis, we can say that the gradient is actually undefined. So how to make this dy dx undefined? It's very simple. You just need to let the bottom part here, the denominator, equals to 0. Because for a fraction, whenever the denominator is equal to 0, it's undefined. So for the part 2, you just need to make sure this part, the y squared plus 2xy, is equals to 0. From there, try to figure out the points. So now for the part 2, you need to let the denominator, which is y squared plus 2xy, equals to 0. From here, you have to solve this equation to get the coordinates. So what we need to do is factorize the y. Then you have y plus 2x equals to 0. So from here, we can get two solutions. One is y equals to 0. The other one is y plus 2x equals to 0. So there's a common mistake here where from this step here, what students do is they will put the 2xy to the other side, and then they'll just cancel the y, and eventually you'll get y equals to negative 2x. This is just one of the answer which is equivalent to this equation. But what about the other solution? Where's the y equals to 0 solution? For this equation, if you cancel off the y, that means you only get one answer. The other solution will be missing. So you shouldn't do this method. The correct method is to factorize the y, and hence you get y equals to 0 as the other solution. So please take note here. And after you got these two solutions, y equals to 0 and y plus 2x equals to 0, then what should we do to solve and get the coordinate? We should always substitute these two solutions into the original equation. So where is the original equation? Have a look here. Let me jot down. The original equation should be 2x cubed minus y cubed minus 3xy squared equals to 2a cubed. And hence, when y equals to 0, we will have 2x cubed equals to 2a cubed. Therefore, x cubed equals to a cubed and x equals to a. Hence, the solution will be a 0. While for the other solution is by substituting y equals to negative 2x into the original equation, then we will have 2x cubed minus negative 2x cubed minus 3x, and substitute the negative 2x squared equals to 2a cubed. Simplify this, we will have plus 8x cubed minus 12x cubed equals to 2a cubed. And from here, you will get negative 2x cubed equals to 2a cubed. X cubed should be equals to negative a cubed, and x equals to negative a. So for this, you just need to sub in here to get back the y coordinate, which is equals to 2a. And hence, the solution should be negative a, 2a. That's how you solve for this equation to get the 2 points on the curve where the tangent is parallel to the y-axis.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. Genius Hub will get genius teachers to fulfill your request for the solution. Genie, we'll see you next time. Bye-bye.